So I'm going to talk about web performance in the age of HTTP2. My name is Holger. I live in Hong Kong, but originally from Germany. And you can find me at Bartel on Twitter if you have VPN here. Or I even have a Sina Weibo account, which I hardly use, but I might be on there sometimes. So it happens all the time that at the train station, everybody's got to do it. Then sometimes at the airport, it's kind of like the same thing. Then sometimes maybe you want to go to a club. And again, also at clubs, you have to do it. Then there's like other times where you might want to get a new iPhone, and the same thing happens. And other times, maybe you want to just get like a new book that has just been released. You also have to do it. It happens in restaurants and also at the immigration. And, of course, on the web. So what I'm talking about is waiting. Everybody's got to wait, and nobody really likes it, but we all have to do it all the time. It's been like that for a very, very long time. So I looked up the definition of waiting, and what it says, I'm just going to read that here. The action of staying where one is, or delaying action until a particular time or event. So what struck me was like there's two keywords in there, and that's actually delaying action. And nobody actually really likes to delay action, because once we want to do something, we would like to do it immediately, or at least almost immediately. And sometimes it gets in your way, and you really like, oh no, I don't want to wait because I just want to get through immigration or something like that. So this is why a lot of people came together and started to be geeking out basically on something called web performance. And web performance aims to make things a little faster. So actually actions don't get delayed so much. So there's like in web performance, there's a lot of user expectations. When users like use the web, there's like a lot of expectations that they have, and like one of them is like that users expect sites to load really fast, and like 2 to 3 seconds is about like a normal time that users expect things to happen. It's not saying that this is actually the time it happens, but that's what they expect. So a user's definition of fast is basically somewhere around that time. Then there's also the web performance group, and we are also like aiming to deliver something, basically getting something on screen even faster than that, whereas I think that's like actually still quite a good number. So 50% of people say they will leave a site if it takes longer than 4 seconds to load. Then we have others. It depends on the location. Sometimes that might be longer because like the infrastructure isn't just right there. Or more than 10 or 8 seconds, I find, is like kind of pushing it a little bit because nobody really wants to wait that long. There's a neat table of like user perception here. If you look at that, you see like, okay, until 100 milliseconds, that's like instant, and then it goes down until like 10 seconds, where people just abandon the task. And I think if we're like somewhere in that midfield, or like in the, well, 1 millisecond is already like really, really fast. But this is like quite a good overview of like user perception. So the unofficial rule of thumb is like 250 milliseconds like to paint something on screen. So our logical conclusion that we're drawing from that is faster is better. And I think everybody would agree to that. So whoever agrees and thinks this is like right, lift your hand, raise your hand. So everybody probably thinks that. So let's look at the impact of performance and like why you should actually care about that and why it is important. There's a lot of statistics and research been going on over the last couple of years, and they all suggest, okay, there's like a certain benefit, a measurable benefit that like goes hand in hand with like performance optimization. So all the big companies, and I'm sure also Facebook is one of them, like that would be interesting to actually see some stats from these guys. But I do think a lot of companies have delivered enough proof to make a point and why it is actually important and like worth investing in. So if we look at network speeds like around the world, then we'll see, okay, actually there's like a lot of great networks out there, and like throughput seems to be very high. So let's say like we have downloads of like 20 megabit plus, and for mobile it's also really high. It's actually like already a little bit older. I couldn't get newer stats because that site went down. So just welcome to the web. But there's a table here that's also a little bit older because it's from the same site, but it basically says, whoa, every country is like really fast. Then some other more like underdeveloped countries, you see it's dropping already, whereas like in the US, it's like pretty damn fast. So overall, everybody goes like, hey, this is awesome, sounds pretty great, we can build big sites and transfer data like no tomorrow and just go for it. But then, on the other hand, and I'm sure everybody has experienced that as well, there's like other edge cases where you come into situations where suddenly your fast network isn't as fast anymore. And this happens like on trains, or even like, I mean, this even happens like in Germany. When I go to Germany, suddenly I'm on the train and it's GPRS. And I'm, whoa, this is crazy. It's like 2015, 16, and it's really, really slow and painful. And then there's other times when you travel. This is like Indonesia, for example. If you're in Indonesia, or especially in the Philippines, I've been to Manila quite a few times recently, and the network there is just, it's bad. I mean, it's sometimes even like no network. So this is like the edge cases, and like where, again, we're coming to the conclusion, okay, faster is better, because like otherwise we're not able to deliver anything. And I'd rather have like something or a little bit than just like zero. So over the last years, we can see all the sites, like the page weight has gone up so much, and it's going up and up and up and up and up. And there was like this little dip there. I think that was like somewhere around last year. And everybody in the performance or interested in performance was like, oh yeah, this is awesome. But that didn't last long. All right, so let's talk about how we actually build for performance and how we make things faster. So this is like the more interesting part, I think. There's like a lot of performance techniques today that we use all the time, and I'm just not gonna go into too much detail here because otherwise we would be running out of time. But generally, it's all about concatenation of files to limit requests. Then we have like image spriting, which is combining images into one, so we again can save some requests. Inline images, again, like data URIs and stuff, is kind of like also aiming at the same thing. And then there's like another performance optimization technique, which is domain sharding, which basically means you're pulling assets from different subdomains, for example, or from different origins, so you can open more connections at the same time. This is all kind of helping to decrease requests and make things faster. But actually before or after that, we still need to render pages, and this is quite interesting because it's like one of those areas that has gotten a bit of traction, but I think it's like let's say like this is performance, like a little bit of the advanced level is like rendering pages and how do we optimize for faster rendering. So a little bit of background to that, because like actually until a page gets rendered, there's a lot of work a browser has to do, and that starts like basically with like waiting for the DOM and the CSS object model to build the page. Then the render tree contains the nodes which needs to be rendered. Then again, layout computes position and size. And after that, Paint actually turns the render tree into something you can see. So then there's like something called render blocking. And there's like certain things that do block the render of a page. And one of them is like CSS, because actually the page has to wait for the CSS to load to avoid the flash of unstyled content. And this is like, basically, if you have like a large CSS file, the browser takes all the DOM and then it reaches the CSS, And before it continues to actually build the page, it will first read and load like the CSS file. The same goes for JavaScript. JavaScript is also render blocking, and basically the script will be executed before the browser continues to build the page. So this is why we used to actually put JavaScript files, or actually still do, put them in the footer, because every request fetched inside the head will actually also additionally delay the request or have like another 200 millisecond request. As I've mentioned before, limiting HTTP requests is like also something that we've been trying to do all the time. And this is why we like kind of concatenated files and like just to limit those and get rid of all the 200 milliseconds that are required for every request, because otherwise those add up, and well, with 5 of them you're already at a second. So there's something called optimizing for the critical rendering path. And optimizing for the critical rendering path is basically just taking a critical resource, which is render blocking files and stuff, and the critical path length, which is like how long it takes to actually load that file, plus the critical bytes, which is like all these resources, like the file weight of those files, and would optimize for that. And the reason we're doing that is because we want to actually get stuff on the screen as fast as we can. In the past, there was like something that you could, for example, extract all the CSS for you above the fold content, and then load that first, and all the other CSS and JavaScript would go or would be loaded later. So you can actually show something, paint something fast, and then everything that you don't need, you just like load after that. So a lot of times nowadays, I come across things like this, where you reach a site and you look at their source, and then suddenly you find, I don't know how many is this? Oh, 35 CSS files. So basically, if you stick all of those 35 CSS files in the head of the page, then all of these files will be loaded before anything gets painted on the page. So, which obviously, if you remember like every request 200 milliseconds, you do the math, it's going to take quite some time. And that's like reflected in that status bar down there. 2.3 minutes, and that's actually quite long. Whereas like load time is like 9 seconds, but that's still quite long. So this is like something that you see all the time. It goes for like JavaScript the same, 31 files, quite a lot, I'd say. It happens a lot to people who use like WordPress themes and just like out the box. But generally that's like quite a lot. 240 requests in total. Under most circumstances, that's like way, way, way too many. So you want to try to reduce those in the first place. There's another example, 111. That's also quite a lot. So let's have a look at the protocol that actually transports all of this, because this is like when it gets interesting, and what I said just now with like, okay, so far this is like bad, but in a second you will see why it's actually not that bad maybe in the future. So let's have a look at the HTTP protocol history. So it all started out in 1991 as HTTP 0.1. So that was like the first version actually of the protocol. Very simple protocol. Send a request, receive a response, close the connection. Very, very simple, but it did the job. So then it evolved to version 1.0 in 1996. So that was like a bit more advanced, but still kind of like simple. They added headers to it and all these things. So then came like another update, which was like 1.1. That was like in 1991. And again, like a bit more sophisticated, but still nothing that we were like kind of, or that was like the final end game. So HTTP 1 actually introduced something that was called like limiting TCP connections, and it was supposed, or the spec said, a single user client should not maintain more than 2 connections with any server or proxy, which most browsers nowadays have actually extended that to about like 6 TCP connections, like per origin simultaneously. So this was like already quite good, but we had to live with it, but now it's like getting even better. So the interesting part is like that actually increasing bandwidth doesn't make it much faster, or like doesn't increase our performance by very much. A little example to that is like if you take like a pipe and you want to like pump some water through it, like the diameter of the pipe will actually allow you to get more water through, but the length of the pipe will still be traveled. So your water still has to go from the beginning to the end. And this is basically what's like reflected in a round trip. But let's have a look at a graph that displays how performance gain you actually get from like increasing the bandwidth. You can see even if you go from like a 1 megabit connection to 10 Mbit, is like the performance doesn't increase much more over like 10-folding the connection. And this is quite an interesting aspect of HTTP1. So round trip time, as I've mentioned, round trip time actually does make a much more, or like a much bigger difference. And it's actually great. Now I can actually make that, like demonstrate that. So this is the round trip time. So I walk over here and it's going to take me some time, and I get like fetching the DNS lookup, and then I actually have to get that back to the browser agent. So that's to user agent. So that's actually kind of cool because I can walk around. So this is the round trip, and it takes me like a certain time. And if you have to do that like many times, your impact on performance is much bigger than like increasing bandwidth. So let's have a look on like the performance increase with like limiting or like decreasing the round trip time, and you will see that is quite massive, and it gets like really smaller and smaller. So once latency decreases, you have much more performance gain in the end. So this is quite interesting. And there was recently, last week was like SmashingConf, and I saw a tweet which basically best describes that as HTTP2 produces the biggest performance gain on mobile because it remedies high latency. Because on mobile you have like a lot of these round trips, and it makes a bigger difference there. So let's look again at this graph. I find it like quite staggering because it's really cool what the impact is. So to actually solve this problem, Google had like an experiment, and they called it Speedy, which basically was like an experimental protocol that they developed in 2010. And it was like developed to actually address those problems. So one of the things they implemented in that was like multiplexing. So multiplexing basically allows concurrent requests across one connection, which kind of limits those like all those round trips you have to do, which is quite good. And then also browsers are allowed to prioritize assets. So vital resources come to the page first, and you can like create dependencies. So let's say you have index HTML, and then you can specify, okay, if the browser requests this index HTML, you can tell the browser, okay, you actually also need this CSS file and this JavaScript file without actually requesting for it. Like the server just knows, which is quite magic and quite cool. Then there's also compressed and reduced headers, which also makes an impact. And then there's also something called server push, which allows the server to push resources to the user agent, which kind of like I find is a bit of an experimental feature because it hasn't been implemented so well yet. But then HTTP2 came along in 2015, and they took a lot of the Speedy things and put it into their protocol. So basically, HTTP2's definition is like a networking protocol for low latency transport of content over the web. And as I said, they took a lot of inspiration from Speedy, put that in HTTP2, and the main features we find there and that also make a difference nowadays is what I just mentioned: multiplexing, compressed headers, asset prioritization, and dependencies, as well as server push. Again, this saves the client time to actually ask for those resources because they're just being pushed by the server. So quite neat. All right, so let's talk a bit more about HTTP2. So first of all, it's backwards compatible with HTTP 1.1. So if you actually don't want to do anything, then you don't have to do anything because things will just work as they did. That's good news in general because a lot of times things just break. So a lot of things changed And how do we actually now build for the new protocol? How do we optimize our pages for that? First of all, I want to talk about what we actually need to make it happen. What do we need to support HTTP2? And this is an interesting one because first of all, you need a TLS connection, which basically means you need an SSL certificate. Usually that's a bit of a troublesome because you have to pay for it and you have to kind of like go through the authority and kind of apply for one, and then they're not really cheap. But now there's like a new initiative called Let's Encrypt. I hope that's not blocked in China. I haven't actually checked. But this is awesome because they give you a certificate for free. This already kind of evens out that big step because this is required. Without that, no HTTP2 support. Plus also, it actually, you can leverage like on a lot of other additional benefits of SSL, which I realized this was like kind of a bit of a interesting one to bring that up in China because Google actually does factor SSL sites into their ranking, search ranking, and I don't know if Baidu actually does that now. That would be an interesting one. If anyone knows, I would be really interested to find out if Baidu also kind of prefers mobile optimized pages and SSL pages and all of that. Really interesting. And then also in the future, some HTML APIs will also require SSL, and like geolocation is one of them, for example. So by getting a certificate, you can also make use of these positive side effects, which is also quite good. Then to serve HTTP, first of all, well, you need a server to actually make use of it. Either you have to upgrade your server with like, for example, Apache with the HTTP2 module. I'm sure other servers also support that by now. The easiest way and a very convenient way to do it is Cloudflare. I'm sure also other CDN providers might offer that, but this is the one I'm using right now because it's really like the easiest way to get to HTTP2. So basically you just have to change two DNS servers, set up your site, and you're all ready to go. Boom, H2. So that's quite easy. The other thing is like users, of course, need browsers that support HTTP2. And as we can see here, as of today, it's quite a lot of the recent ones. Chrome has been on it for a while, Firefox as well. But if you're targeting any of those browsers, then that will work as well. An interesting aspect, which I will elaborate later on, is like what's your user base that actually has those browsers if you're thinking about moving to HTTP2. And then up there, you can actually see the support in Hong Kong is like 74%. In China, it's only 35%, and global is 63%. So you can already see, like, I mean, that tells a lot about like the browser market out here. I'm not really up to date with like the stats of like China browser usage, which would also be very interesting to get some more insights on. I don't know if Internet Explorer 6 and 7 is like still super big, but that would be something to have a chat later. Because of that, some things aren't right anymore and we have to change. So some of the great performance techniques we've used so far with HTTP1 now have become anti-patterns, and we want to look at those. So from HTTP1 to HTTP2, what has changed? And I think this is like what you've all been waiting for, the magic moment. One of them, for example, is concatenation of files. So in HTTP1, there was like this lack of parallelism where, what I mentioned earlier, you could only have like 6 requests or TCP connections open to the same origin at the time. And all of this is now gone because HTTP2 can do multiplexing and we don't have to work around that anymore. So this is like, while combining multiple files, we don't need to do that anymore. We can just load them all, and that's much better. But it takes like a lot of actually rethinking of a lot of things. So requests are cheap now, which kind of like what we've seen before. Those inspector screenshots I've shown, 200 requests. Before I would be like, oh my God, who does that? That is like way too many. And now it's kind of suddenly, oh yeah, it's actually not that bad. So it's kind of really, well, I wouldn't call it paradigm shift, but it's definitely a shift in like thinking about requests. So now that we've all set up our like build processes with like grunt and gulp and whatnot, check. Now we have to actually revert them basically. And like before we would be combining all the files into one, and now we have to kind of rethink that. Okay, we don't need that anymore. It's actually quite okay, I think, because the whole build tools have gotten slightly out of hand in my opinion. But now we can actually leave partial files on their own again, and this also allows us like to update like caching policies accordingly, because if you only have like some modules that might change a lot and frequently, you don't have to like update all the files. It's basically you just have that like tiny file for whatever module, and then you can adjust your caching policies accordingly, and you don't have to like kind of wipe it all again. Maybe it's also going to make our code structures a little bit easier again. Who knows? We'll see that. So looking at this again, we have like 240 requests. Yay, requests are cheap. You could theoretically do that. I still think maybe it's a little bit too much, but in general, you don't have to worry about it so much anymore. Another thing that has changed, which is not needed anymore, is like image sprites. So this again, also for the same reason image sprites were invented, just like to keep requests down. I have had a conversation earlier where it was like, let's see how actually it turns out, because a lot of times this is like theory, and sometimes you might get away with like better compression if you have like some images as a sprite and some maybe not. It really depends on what kind of project you're working on, and I think time will tell how to best proceed on that and how to best work with these new approaches. So another thing we used to do, or like to do, was like inlining images. You just base 64 an image and put it straight into your HTML file to again make up for another request. This is also not needed anymore, and it also affects your caching options. So also the prioritization can't be used. So all in all, no need to do that anymore, because again, requests are cheap. We can just do that. One more is domain sharding. I'm not sure if everyone is familiar with that, but it's basically requesting assets from subdomains or different origins. So you can actually open multiple TCP connections to get those files, and this allows you to extend your connections. In theory, also unlimited, but usually it's more like should be kept down. I'll come back to that in a little bit, because there's a nice overview. And to add to this one, the reason why it actually has a negative impact on HTTP2 is because with like having another origin, you're opening up another connection, which basically costs you another round trip time for DNS lookup and so on, which in HTTP2 you don't need, because you can just like pipe it all through one connection. So this is the reason why it actually has a negative impact. So all in all, in a nutshell, this is probably the overview that answers all the questions. This is what stayed the same and what hasn't, or what has changed. So if we look at that, reducing DNS lookups generally is a good idea. Reuse of TCP connections is always, for both protocol versions, a good idea. Content delivery networks as well, and HTTP redirects, which I haven't mentioned before. Also, every redirect does cost you additional time. So generally, it's a smart idea to keep those to a low number, or as low as possible. Eliminating unnecessary request bytes, which basically means keep your file sizes as small as you can, because the data has to be transferred, and that, again, doesn't matter over how many connections you do that. If your CSS file is 1 megabyte, then you definitely did something wrong. And compressing, like gzip, is also a very, very effective measure that you can use. caching resources on the client, which you can also set, and unnecessary resources basically means like don't load files that you don't need, which can be images and can also be visible when you're having, for example, you're loading large images or image sprites, even in that case of a lot of things you actually don't need for one page. And this is again another advantage now that we have like with loading smaller parts of CSS and JavaScript, because you can basically say, okay, for this one page, I actually only need this small extra snippet of CSS and maybe this small JavaScript file, and for that page you only load these two, instead of like loading the whole application or site, whatever you're doing there, at once and all the time. So you can actually be much more granular, and it makes sites much smaller. Then, as I just mentioned, domain sharding is not such a good idea anymore. You can still do it, but only in HTTP1. And if you do, don't use more than 2 host names for that. Concatenating resources in HTTP2, you don't have to do that anymore, because we said requests are cheap. And remember that, they're very cheap, and that's awesome. And then inlining resources, basically like the base64 for inline images, or however you want to do that. You can still do that, but in HTTP2, it's not a very good recommendation, and it can probably be easier solved by like server push, or even just like loading a normal image. So this is like basically a good overview of like what has changed and what hasn't. So now you all go say, well, hey, this is awesome, I want that. And what's your action plan? What do you need to do? So let's talk about how to actually get to HTTP2. So first of all, as I said before, you will need a secure connection. Get a TLS connection, get a certificate. Maybe you want to try that. I would be really interested. Let's Encrypt should work actually here, but maybe someone can try, and that will be interesting. So, but first of all, get a secure connection, get a certificate, and then move from there. So the second thing is actually you need to prepare your build process to support that. So if you're now like concatenating all the files, you have to think about a way of actually changing that, so you can output different files for your new build at some point. You can do that right away, or you can just like prepare. Usually I think it's a good idea to just like prepare your whole setup, and the TLS basically you can add the secure connection at any time, because it will only benefit you, except for that little handshake penalty that you get, but that's like minor, I would say, for the benefit of what you actually get from it. But prepare your build process to kind of have everything in place, so you can at some point just switch it. And then an important thing, you actually have to find out, does my user base actually support what I'm planning to do? So again, we've seen the table of supported browsers. You should check your analytics and see, okay, what's the majority of my users using? And then at some point, I think you have to just decide, okay, what's my tipping point, or like what's my point of where I say, okay, I can actually switch now. Because if it's like only 20% supported, or like even like 35 that we've seen like for China, I think that's a bit critical. But if you're like maybe at 35 or 90 or something, then it's more likely you can make that change. So, and of course you also need a server that actually supports HTTP2. So either you build your own, or you have your own, or worst case, I'd say you have to find a hoster that actually provides servers that support HTTP2. So, and then you can start implementing your best practices and kind of play around and see what's like the best, what actually does work for your specific site, app, or whatever you're running. And one important thing to note is that once you have implemented all these like best practices and like kind of have like optimized for performance on HTTP2, this might have like a little impact on HTTP1 browsers or users. So I don't know how big that will be. It's kind of like, again, I think it will show over time. Once it's getting like a bit more popular and like widespread, we will probably see a bit more, okay, how much does that actually affect other users. But I think in general, the way forward is HTTP2. So if you feel comfortable and you have the user base to actually support that, I would suggest try it out, give it a go, and enjoy. Thank you very much.